Hello there, Mr. Sutton here with the Pre-Cal Honors 9-1 Part 2 homework solutions on finite intuitive limits. For this problem, we have this graph about which we're asked a whole bunch of true-false questions. Here's parts A through C for that. So for part A, limit as x approaches -1 from the right side equals 1 is what they're saying here. So we take a look at the x value -1, and as we approach that from the right side like so, are we heading toward the y value 1? Well, we are, so this is true. For the next one, limit as x approaches 2 of f of x does not exist, so let's take a look at the x value 2. Now, as we approach the x value 2 from both the left and the right side, we're heading toward the same number, 1 specifically for the y value. So because we're heading toward the same number, because the left and the right agree, we would say that this limit does exist. In fact, it's 1 for the limit for this. So the statement that it does not exist is false. And then for part C, limit as x approaches 2 equals 2. Well, we already established that it was 1 in part B here, so this is another false statement. Now we're doing parts D through G of that true-false question. So for part D, limit as x approaches 1 from the left side is what that is saying. They're saying it's 2. So here's the x value 1, and as we approach this from the left side like so, are we approaching the y value 2? Well, we are. So that is a true statement. Next, they're saying limit as you approach x equals 1 from the right side, that's a plus there, equals 1. So let's take a look as we approach the x value 1 from the right side now. So we'd have to approach right from this direction, and we are going toward the y value 1, so that's also true. And then limit as x approaches 1, two-sided limit now does not exist. Well, the left side limit and the right side limit at x equals 1 do not match up. Because there's a mismatch between those, this is a true statement. The limit does not exist. And then for the next one, limit as x approaches 0 from the left and the right are equal to each other. So let's take a look at x equals 0. So as we approach from the left, we're heading toward the y value 0. As we approach from the right, we're also heading toward the y value 0. So that's going to be a true statement. For parts H and I of this problem, H, they're saying the limit as x approaches c of f of x exists for every c in -1 to 1. So they're basically saying the limit exists for all x values between -1 and +1. So really we have to ask ourselves, are there any places where the limit breaks down, any breaks at all really? And if you look between -1 and +1, there are no discontinuities of any kind in that interval. Since there's no breaks at all between -1 and 1, this is a true statement. The limit does exist all places in between those numbers. Now, it doesn't exist at exactly 1 because your left and your right limit are going to different numbers, but they didn't include 1. This is an open interval with these rounded parentheses. Now, for the next part, they're basically asking the same question, but now they're asking about all the numbers between 1 and 3. So does the limit exist everywhere between 1 and 3? Well, there is a break here. It's this spot right here. So this is really the only trouble spot that we have to be aware of in answering this question. Does the limit exist at x equals 2? Well, from the left and the right side, you're heading toward the same y value as you go towards x equals 2. So this limit exists as well. Since there are no non-hole breaks between 1 and 3, because the limit exists at holes, it's just a pothole in the road that you can kind of just skip over. Because there's no non-hole breaks, that means that this is also a true statement. The limit exists everywhere between 1 and 3. For this question, we're trying to estimate the following limits on the graph over here. So starting with part A, limit as x approaches 0. So looking at the x value 0, as we approach from the left and the right, we're heading toward the y value 1. Next, as x approaches -3, so going over there, from the left side, we're going towards the y value -2. Same thing from the right side. Since those limits match up, our limit there is going to be -2. For part C, as x approaches 4, so that's over here. As you go from the left side, you're heading toward the y value 3, and from the right side, you're also heading towards 3, so those match up with a limit of 3. And we have this solid dot down here, but that doesn't affect the limit. It's all about where your function is heading towards, not where it actually ends up at the exact spot. Part D, limit as x approaches -4, so now we're all the way back here. And as we approach from the left and the right, we're heading toward the y value -3, so that's the limit there. Next, this is q of -3, so basically if you plug in -3, what is the y value there? So at -3, the function value at x equals -3 is wherever the solid dot is. In this case, that's 4, so that's different from the limit. And then for the next part, q of 4, that's again the solid dot at x equals 4, which is at the y value 1 right here. And then finally, q of 0, well, the only part of the graph on x equals 0 is this open dot. There's no solid anywhere on x equals 0. So therefore, the function does not exist at that spot. For this problem, we're trying to find limits and function values for the function represented by this graph. So our first question, we're asking for f of -3. So over at -3, we see we have an asymptote. They're asking for the function value. Either way, though, if you ask for the limit or the function value, that's going to be undefined, does not exist at that asymptote. For part B, we're asking for the limit as x approaches -5. So that's over here. As we approach from the left and the right, we're heading toward the y value 4. So that's the limit for part B. For part C, we want the limit at -1. So down here at -1, as we approach from the left and the right, we are heading towards the y value -1. And then finally, we're asking for limit as x approaches -3. Now, we kind of talked about this earlier. As you approach -3 from the left, you're going to positive infinity. As you approach -3 from the right, you're going to negative infinity. The limits don't match up, so that's going to be does not exist. If they did go the same direction, then you could claim it was that kind of infinity. Even then, though, it's kind of just does not exist with direction. For parts E through G of this problem, we're going to take a look at the same graph and do a few more limits. So E, we want the limit as x approaches 2 from the left side. That little negative means there. So here's 2. As we approach that from the left side, we are heading toward the y value 1. And then for part F, now we're approaching 2 from the right side. So that means we have to go up here and approach from this side. And that's bringing us toward the y value, let's see, that's 6. And then we want the two-sided limit at 2. Since the left-sided limit and the right-sided limit do not match up, that means that the limit at x equals 2 is actually going to be does not exist. For this problem, we have this function with lots of interesting features that we're trying to find some limits for. So for part A, we want the limit as x approaches -3 from the left side. So here's -3. Approaching that from the left side, we're heading toward the y value 0. Next, we're trying to find the limit as x approaches -6. So here's -6 over here. And as you approach from the left and the right, you're heading toward the y value -4 for that one. Next, we're approaching -1 from the right side for part C. So here's -1. Approaching from the right side, that brings us to the y value 2. It would have been the same from the left side as well. And now we're approaching 4 for part D. We're approaching 4 from the left side. So over here at +4, as you approach from the left side, well, we find that we can't actually approach from the left side. We can't approach 4 from the left because we're stopping at 3. So because we're not actually approaching it, we're going to call that DNE. For parts E through I, on that same question that we just did A through D on, we're going to do a few more limits and a function value. The first question is actually the function value of the function f at -3. So over here at -3, we're looking for where the solid dot is if we're asking for the function value. So that's actually going to be all the way up here at +6. And then for part F, we want the limit as x approaches -4 from the left side. So here's -4. Approaching from the left side actually brings us to this branch down here. So we're approaching -6 if we come from the left side. And then as x approaches -4 from the right side, well, now we're up here with this kind of parabola-ish shape, and we're approaching from the right side the y value, I don't know, that's somewhere between -2 and -3. I'm going to call that -2.5. They did say estimate the limit, so that's what we're doing. For part H, we want the two-sided limit as x approaches -4. Now, since the left side and the right side limits do not match up at -4, That means that that limit does not exist, dne. Finally, for part I, as x approaches negative 3, we want, let's see, from the left and the right, we end up with the same number. That's going to be the y value 0 that we're approaching there. Even though there's a dot up here, that doesn't really affect the limit. So 0 it is. On this question, we're trying to estimate a few limits for the function f represented in this graph. So for part A, we want the limit as x approaches 0 from the left side. So here is 0. Going from the left side to get there, it looks like we're going up to the y value 4, so that's our limit from the left. For part B, we want the right side limit. So at 0, to approach from the right side, we have to start here-ish and approach from this direction, giving us a y value of negative 3 down there. Now we want the two-sided limit at 0. Since left and right are not the same limit, that means that the limit at 0, the two-sided limit, does not exist. And then finally, we want f of 0. That's the function value at 0. So that's this solid dot up here at the y value 4. On this problem, we have this graph of f, and we want to know the limit as x approaches 1 of this f of x graph. So we have to look at the x value 1, and this is the two-sided limit since they didn't specify one direction. So we have to look at both the left and the right-sided limits. So as we approach 1 from the left, from this direction, our limit's going to be 3 up here. And then as we approach 1 from the right side, that's going along this horizontal line, that brings us to a y value of 1. Since the left and right do not match up, that means that this limit does not exist, so that's choice D. For number 7, we've got a graph of a function, and we want to know for which values of c does the limit as x approaches c equal 1. So which x values have a limit of 1? Now, we could look at all the x values here, but since it's multiple choice, we only have to look at some of them. Notice in our answer choices, we have 0, -2, and 3 as the only possibilities they care about. So let's just look at those values. Looking at -2, as we approach from the left and the right, we have a limit, a y value of 1. So -2 is a yes. We're approaching 1 from both sides. How about 0? Well, at 0, as we approach from the left and the right, we're also approaching the y value 1. So 0 is a yes. And the only other possibility we care about is 3. So as we approach 3 from the left, we end up with 1. As we approach from the right, we end up with 1/2. So that's not true. 3 doesn't work. Different limits from the left and the right. So that means that only -2 and 0 are correct, which is going to be choice C. For this problem, we're given the graphs of f and g, and we want to know which of these statements is false. So this is process of elimination here. Let's go through these one at a time. For choice A, we've got the limit as x approaches 1 of f of x equaling 0. So as you approach from the left and the right side, we are indeed approaching a y value of 0, so this is true. For B, we've got limit as x approaches 2 of g of x does not exist. So here's the g function. At x equals 2, as we approach from the left, we're at +1. As we approach from the right, we're at -1. The limits don't match up from the left and right, so this is a true statement. The limit at 2 does not exist for the g function. Different limits from each side. Now, choice C is where it gets a little bit tricky. They're saying limit as x approaches 1 of f of x times g of x plus 1 does not exist. So for this one, we're going to take a look at the left and the right limits as well and see whether or not they match up. So for the left side limit of f of x as x approaches 1, we're coming to the y value 0 right here. And now for g of x plus 1 as x approaches 1, we're basically asking as we approach 2 from the left side, that is a value of 1 right here. So we've got 0 times 1 for the left side limit of this whole chunk of stuff right here. Okay, now let's take a look at the right side limit. Coming from the right side, we've got 0 for the f function. And over here for the g function, we have a different number now. We have -1 coming from the right side. Now, at first glance, you might think that since this function did not have a limit at 2, multiplying by a limit that didn't exist was going to make the bigger limit not exist. But in fact, what do we get when we actually crunch the numbers here? For the left side limit for this stuff, we end up with 0. For the right side limit for this stuff, even though it doesn't look visually the same numerically, we still end up with the same y value of 0 for the whole output here. So these are equal. That means the left and the right limits are equal, which means that this limit does actually exist. So this was kind of tricky. This ended up being a false statement here. And just for good measure, let's take a look at choice D. So we've got limit as x approaches 1 of f of x plus 1 times g of x exists. So basically we're looking at the limit for the f function at 2, and that limit absolutely exists. From the left and the right, you're ending up with about -1. G of x at 1, that's over here. From the left and the right, you're ending up with 1. So if you're just multiplying two numbers that are exactly the same from the left and the right by each other, your overall limit definitely is going to exist. So this is true. So by process of elimination, you could have chosen choice C, but this is why choice C ended up actually being false.